Okay, today is food and nutrition. We're going to talk about the fattening of Western society. This is David. You might recognize him. Looks a lot like me. And what's happened over the last few years is disturbing. There does seem to be a bit of a problem. People tend to be getting heavier and heavier. That's not healthy. It's not good, it's not healthy. It's much less attractive than the other David. How do we measure degree of fatness? Well, we do this with what's known as the body mass index, BMI. BMI is this very strange formula. You take the weight in pounds, height in inches squared of all things, multiplied by 703, not 700, 703, and you wind up with a number. If you're below 18 and a half, you are considered underweight. Normal, 18 to about 25. I'm about 23. Overweight, more. And obese is considered to be anything 30 and above. Now, people didn't used to worry a whole lot about how large their neighbors were. But in about 1985, the Center for Disease Control started keeping track of it. And as you can see from the map here, there wasn't a whole lot of data from a whole lot of the country because nobody really cared. But what data there was, these are percentages of adult population that have BMI over 30. So that makes them obese. Now, obese is a real health hazard. It really is. Lots of bad things happen when you hit above 30. So in 1985, this is kind of what the map looked like. They followed it for years and years after this, and here's kind of what it looks like. 87, we see a lot more of the blue. The blue is 15 to 19%. Dark blue starts to show up. Lots of dark blue. By 97, we get yellow. That's 20 to 24%. My goodness, these guys are turning orange. And by the time we hit 2007, we've hit the limit of this scale, which is above 30% of the population being obese. The South is really bad about this. We're not so bad here, but all around us isn't doing so well. What does it look like today? Well, it's worse. It's worse in such a way that they actually had to change the scale, change the coloring. Now this dark orange is above 35%. And again, you've got the deep south here, West Virginia. And we're up here in the region of 30 to 35% of people that you know are considered obese. That's bad. That's really bad. West here is not so bad, except Oregon. DC is skinny. That's because the administration that was there were all skinny. We'll talk about them in a minute. But yeah, so that's skinny there. But the whole middle of the country here really seems to be having a problem with obesity. Now, when you move, when you breathe, when you do anything, it burns energy. The amount of energy that it burns is referred to as the basal metabolic rate, BMR. BMI tells you how large you are. BMR tells you how much energy you burn. And for males and females, it's slightly different. And again, it's a very bizarre formula. There's a notion called calorie in, calorie out. Now the BMR tells you how much it takes just for you to lie still, breathe, have your heart beat, and still live. You can modify the BMR by how much you do. If you just sit there, you take that, multiply it by 1.2, and as your activity increases, so you get down to somebody that goes to FFC every day, BMR basically multiplied by 2. So if you happen to be a 30-year-old male at about 175 pounds, moderately active, it would take about 2890 calories a day to run you. About 2890 just to keep you alive. Okay. Calorie in, calorie out is kind of an old-fashioned notion that if you take in more calories than you expend in energy, you will gain weight. If you take in less, you will lose weight. Now I say this is old-fashioned. It kind of makes sense on many levels, but people's genetics are really different. There are people that the BMR doesn't really work for. Diet, it turns out that exactly what you eat makes a difference. And of course, activity. The more activity you do, the better you are in terms of burning the calories that you take in. Well, people look at this whole calorie in, calorie out notion, and they say, okay, I can do this. I just won't eat anything. I want to lose weight, I won't eat anything. That'll work. Doesn't work. You know why? Because your body realizes that you're not eating anything. And when it realizes you're not eating anything, it thinks, oh my God, you're starving. And so what does it do? It starts eating your left arm. Literally, it starts converting muscle into protein so you can live. If you really want to lose weight on the calorie in, calorie out, there's something called the 1,200 calorie threshold. If you drop below 1,200 calories a day, your body thinks you're dying. If you get above your BMR, you get fat. But somewhere in between, you will gradually lose weight. Okay. Remember the 1,200? That's kind of a useful concept. It is very frustrating if you're trying to lose weight and you really don't eat anything and you get down to the point where, gee, why am I not losing any weight? Again, it's because your body thinks you're starving and it shuts down metabolism everywhere. So you got to remember, got to do it in moderation. All right, there are lots and lots of diets out there. Low carbohydrate diets. When you say low carbohydrate, everybody thinks of Atkins. There's starch blocker, South Beach, no grain, glycemic index, etc. Well, it turns out that Atkins didn't quite invent this all by himself. There's this gentleman, William Banting, in 1796, published this little book called The Letter on Corpulence. Corpulence is a word for the state of being fat. And basically what he said back in 1796 was, if you don't want to be fat, don't eat bread. Eat anything else you want, don't eat bread. Basically, that's the Atkins diet. Now, Atkins didn't actually steal it from him. He stole it from somebody else. We'll get that in a minute. Trendy diets, Hamptons, the Zone, the liver cleansing diet. Oh my goodness. Love your liver. There are religious diets. And my favorite, the diets for the self-indulgent. Ice cream, gravy, beer, pasta, popcorn, and chocolate. The martini diet, and this guy, the drinking man's diet. The drinking man's diet came out in the early 60s. And this is actually where Atkins stole the idea from. This was based on the 1796 stuff. And then Atkins read this and said, hey, I bet I could make a lot of money on that. And he did. Drinking man's diet basically says low carb, you can drink as much as you want. We'll see why in a few minutes. Or you could just say to heck with it and not diet at all. Now, when you consume food, this food is digested, and it's going to go through 3 basic pathways. We're going to very briefly look at the pathways, and the point here is to see how they're all interconnected. Glycolysis. Glycolysis was discovered in the late 1800s. The chemists that did it were just darn near brilliant. I mean, they were amazing. They had no instrumentation, and they did all this stuff from scratch. They were organic chemists, of course. In glycolysis, you're going to take glucose, a 6-membered sugar, oxygen bridge here in the ring, and you're going to convert it into 2 molecules of pyruvic acid. So you're splitting this 6-carbon thing into 2 3-carbon things. In the process, we make what's called NADH and ATP. Those are the substances that run the body. This is metabolic energy. Now, I'm sure you haven't had biochemistry. I really think you should. Everyone should have biochemistry. Make sure it's taught by a chemist. But okay. Glycolysis looks something like this. You start off with glucose. You put on a phosphate. Rearrange the ring into a fructose ring. Put on another phosphate. Then you do what organic chemists call a reverse aldol condensation. And that splits the 6-carbon unit into 2 3s. Once you have the 2 3s, you rearrange the phosphates, eventually get rid of them, and you wind up with pyruvic acid. 3 carbon, this is a carbonyl, and a carboxylic acid. This is the basic source of energy in the body. Pyruvic acid is transported from the cytoplasm, where it's formed, across into the mitochondria. Now, mitochondria are probably bacteria or remnants of bacteria that were incorporated into cells a billion years ago. They keep their energy producing quality, that's why they're still alive. The mitochondria are only passed down through females. That's how you can always trace your mother. And pyruvic acid is transported into the mitochondria, where it's converted into something called acetyl CoA. Acetyl CoA has two of the carbons of pyruvic acid attached to this CoA, which is really just a carrier. And this is, again, the key metabolic thing for producing energy in our body. So let's say that we just had a good time. We sat down with a big pile of bread, and I will say that looked so good, and we pigged out. What would happen? Well, what happens is bread, doesn't matter if it's whole wheat, if it's white, if it looks pretty, if it doesn't. All breads, as soon as they hit your stomach, are converted into sugars. Very, very quickly. Your stomach is darn good at that. Process starts in your mouth. It is so good at that. All right, so in your stomach, you have lots of sugar, glucose. Your blood sugar goes up. The body is designed to tolerate a certain level of glucose. The way it does that is by using the hormone insulin. Insulin detects, well, actually, cells in the pancreas, pancreatic beta islet cells, detect when blood sugar is high, and they will release insulin. Insulin will keep the blood sugar constant. And the way it does that, if you have more blood sugar than you need, it will polymerize it once again into what's called glycogen. Glycogen is just long chains of sugar. And it will take these and it will shove it in your liver, shove it in your muscles, until it's full. You can accommodate about 200 grams total. But once your 200 grams of glycogen are full, what does it do? It's going to convert the sugar to acetyl CoA. Acetyl CoA converts to fat. Fat. Sugar converts to fat. This is an adipocyte, big ball of fat. You know, here's the workings, but basically it's a big ball of fatty acids. And that's what it looks like in real life. So the bottom line here is that if you allow your blood sugar to go high, your body is very good at regulating it. It will take it, put it into glycogen until it's full, and then what's ever left over winds up as fat. The bottom line, excess carbohydrates are converted very quickly, very efficiently by your body into fat. Any question? how to get fat without really trying. Lots and lots of breads, fried food, and whatever. All right, fried food. When you talk about fried food, you're talking about fat. So fat's going in. Fat is converted into, eventually, acetyl CoA by the process called beta oxidation. This is an acyl CoA. So this part used to be a fatty acid. It's been linked to a CoA, the same thing we did with pyruvate. We take this and we remove a couple hydrogens to make a double bond. The body can do this. It's amazing. They can do this. You'll note that this is a saturated fatty acid. Saturated means no double bonds. Okay? Your body converts it to an unsaturated fatty acid. Then it takes that, hydrates it, eventually it's going to cleave it, and it makes acetyl CoA, which does the same thing that it did for sugars, and the rest of it is stuck as a CoA, which goes through the cycle again. So, fatty acids are consumed. Saturated fatty acids are probably the body's favorite. Now, you may not believe that, but it's true. Saturated fatty acids, the ones they say are bad for you, they're really not. Your body metabolizes those really well. Convert it eventually to acetyl CoA. Proteins, the other thing you eat. Proteins are a real bother. The structures are very complex. First thing you do is break them down to amino acids. These are used in lots of different ways. You can make new proteins out of them. You can make other things for your body. You can deaminate them, take the carbon skeleton, and by George, you can make acetyl CoA out of them. But this is a very slow, inefficient process. It does wind up in the same place, but it's slow and inefficient. So our bottom line here, everything eventually winds up as acetyl CoA. This is the little 2-carbon unit, the acetyl unit, that we've stuck on. Glucose gives us 2 of these. Proteins give us these. Fats give us these. And all the rest of this is the carrier in the body called CoA. Now, if everything goes to acetyl CoA, why aren't all foods equivalent? And that's because the rates of the processes are very, very different. Simple sugars, that includes bread. This is really fast. You eat this stuff and boom, you're there. Fats and oils, they're a little bit slower. That's beta oxidation. Proteins really take forever. And interestingly, alcohol, quote, empty calories, which may or may not be real calories, depending on your own metabolism, are very quickly metabolized, but they are very slowly converted to acetyl CoA. So even if they are metabolized by your body, they don't wind up as really useful calories for a very, very long time. So it really does make a difference what you eat in your diet. Sugars, lots of CoA quickly. Fats and oils slower. Protein is the slowest. All right, so what do you eat? The USDA was charged by the US government to inform everybody what they should eat. And so this was actually in the 30s before World War II started. They came out with this. It's a little wheel. And you were told you should eat some of this every day. There are 7 things on the wheel. Well, people kind of looked at this and said, 7? That's a lot. And so the USDA said, well, okay, fine. And so they modified it and came up with the 4. You probably didn't go to kindergarten in the days when you were taught the basic 4 food groups, but I wasn't. Food groups, 4 of them. Meat, dairy, grain, fruit, and vegetable. And the USDA said, eat those. Okay, kind of makes sense. Eat those. Well, life was good for a while. Oh, some people said, you mean steak, whiskey, bacon, and cigars? Whatever. So not everybody bought into the same 4, but you know what? It's whatever. So everything went well for a while. And then in the 50s, we elected Dwight Eisenhower president. Very charming guy, a general from World War II. Turns out that he had a heart attack in office. And everybody was really upset. You know, they rushed him off, they did surgery, they did whatever. When they did this, they looked at his arteries. Now, you know, open heart surgery was something you didn't do in those days, but they looked. And it turns out his arteries were clogged. They were clogged with fat and cholesterol. Now, Eisenhower was a general, and he really liked bacon, eggs, meat, potatoes, etc. And they looked at him and said, all of these have high cholesterol and high fat. That's why your arteries are clogged. So they told him, you could eat no fat and nothing containing cholesterol. Well, that didn't make him happy. He hated the diet, and he died anyway. But the people that did this sent the entire country, and in fact the entire world, on a low-fat diet. Now, mind you, there was absolutely no scientific basis for this. They simply looked and said, oh my gosh, fat and cholesterol, got to be from what he eats. You are what you eat, right? No, not at all. So, by the time the 70s hit, we were on a worldwide, low-fat, high-carbohydrate diet. Not a bit of fat in any of this, huge amount of spaghetti, sauce, good, healthy Coke, wash it down, etc. The government bought into this big time, and of course, every marketing organization in the world bought into it too. And everything came out as low fat, high carbohydrate. Because fat was bad, carbohydrate was good. And what happened? Everybody started getting fat. Well, folks at USDA said, you must be doing something wrong. You're not following our directions. So a bunch of staffers, not scientists, staffers, political appointees, sat down and they said, we're going to fix this. And so they came up with the food pyramid. And they said, we don't want fat, but you want lots and lots of bread, pasta, cereal, stuff like that. Lots of it. You can have some vegetables and fruits, a little bit of milk because you know it's got fat in it. You'll note there is no red meat on here. And tiny bit of fat, oil, and sweet. This was the USDA food pyramid. Once again, it was done without any scientific basis. Nobody was happy with it. Imagine if you're in the beef industry. You look at this and you say, where's the steak? Where's the meat? There is none. And again, all of it with no scientific basis. So everybody, literally everybody, decided they could do better. Sure, this is the food pyramid from the USDA, but vegetarians said, hey, we could do this. Again, here's the lots and lots of bread and pasta, but they moved, veggies and whatever, beans down to the bottom. Again, none of this, and of course, no meat. Mediterranean diet. Meat once a month. Lots and lots of bread and pasta. Asian diet. Meat once a month. Lots and lots of pasta, fruits, and vegetables. A little bit of vegetable oil. Latin American. Actually looks a whole lot like the Asian. That's probably because they all came over together. Mayo Clinic chimed in. They moved carbohydrate up and put fruit and vegetable on the bottom, but lots and lots of veggies, but again, darn near no meat. The college student plan. Ramen, 4 to 6 a day. Beer, wine, unlimited. Pizza, 6 to 8 slices a day. Fast food, and yeah, fruit and vegetable, well, maybe. And of course, the meat lover's diet. Cow, pig, chicken. Well, USDA kind of got the hint. They said, gee, nobody liked our pyramid. Nobody liked it. So we're going to fix it. So they came up with a new pyramid. And the new pyramid looked like this. It had no food at all. No food at all. No food. They did put this little icon on the side, walking up the stairs to say, hey, you should exercise, but you shouldn't. Well, people kind of pointed out to USDA that that was a bad idea, and you need to put food in there. So, well, they did. They modified this yet another time, and they put food in. But if you look at this, it's all kind of clumped here at the bottom. There's no way in the world you could tell what you're supposed to eat or not. It's just all there. But you should walk up the stairs. All right. this was a real issue. Finally, USDA said, okay, this isn't working. We're going to come up with a simpler version. And so they came up with My Plate. This has fruit, vegetables, protein, grains, and a glass of milk. Now wait a minute. Let's go back to 1930 something. Doesn't this look familiar? Meat, dairy, grains, fruit, and vegetable. I think this is like full cycle. And this is our latest USDA recommendation. Well, so what are you supposed to eat? Let's say that we had two options. Look at these two, and what do you think? Here we have a bag of chips and a Coke, and this big fatty steak and a glass of wine. What happens when you eat these? I won't look to see that you have a bag of chips here. What happens when you eat these? As soon as these chips hit your stomach, they are metabolized into sugar. The sugar builds up. If you have more sugar than you need, your body will take it and do what with it? Store it as fat. Now, the chips have fat already. Remember, fat is metabolized slowly. So the sugars have a head start. So what does the body do with the fat? Well, it stores it too. So all of the fat and the excess sugar from this, and especially the Coke, are going to wind up as fat. However, if you eat the steak and drink a glass of nice wine, the body will metabolize the fat faster than it does the protein. So the first thing it's going to do is take all the fat out of this meal, convert it to acetyl CoA, and you will live. And then very, very slowly it will take the protein and convert that to acetyl CoA. As long as you don't exceed your daily calorie requirement, this is going to just go be used and you won't get fat. The thing about the difference between these two is if you eat chips and drink a drink, it does very little to make you feel full. But you eat this steak and you feel really good. And you don't want to eat any more. So you eat this, you stop eating, and again, you don't accumulate fat. Fat does not make you fat. You are not what you eat unless you eat carbohydrate. Fat in the presence of carbohydrate will make you fat because of the differential. The carbohydrate is metabolized quickly and then the fat accumulates. All right, here's a meal. What do you think of this? We look here, we see we have French fries. They actually look pretty good. They have fat and starch. Again, the starch goes instantly into sugar. It's used until you don't need any more, then the sugar is converted to fat. It's drenched in fat, that just goes straight to your lips. This is a Coke. Again, the sugars, this is sugar water. The sugars are rapidly metabolized. Any excess sugars wind up on your hips. A triple bun here. Actually, the meat and the cheese isn't so bad, but all the carbohydrate in here, rapidly metabolized, winds up as fat. The one thing that's good for you is the fried chicken. Protein and fat. As long as you don't eat the rest, you're good. Who would have thought? Now, what's good about this meal? The answer is simply everything. Absolutely everything. We have broccoli, cauliflower, and Brussels sprouts. Now, Brussels sprouts especially taste terrible, but what's good about them is that they contain the organic chemical referred to as an isothiocyanate. Now, your liver has an enzyme called the P450 system. It's an oxidase. The P450 system is capable of taking benign molecules and it oxidizes them into carcinogens. That's a bad thing. But the P450 is very important for other reasons. Turns out that the isothiocyanates inhibit the P450 system. So that's why they're good for you, even though they may taste terrible. Here we have cheese, we have eggs, butter, oil, avocados. Oh my gosh, avocados are so good, they're so fatty. And it's all good fat. Eggs are the perfect food. People vilified eggs for years and years and years. Any registered dietitian you talk to would say eggs are terrible, they have cholesterol. So makes no difference. When you have lots of cholesterol in your body, but that's because your liver makes it. You need it. It makes it constantly. The amount that you eat is a drop in the bucket. You need it. Eggs are the perfect food. And the gushier they are, the better. Colorful fruits and vegetables. There's a very simple rule of thumb. The more color you have in your fruits and vegetables, the better they are for you. These are called flavonoids. They're antioxidants, prevent free radical chain reactions, and they're associated with bright colors. So tomatoes, strawberries, really even the greenies here count. Garlic, who'd have thought? Garlic has sulfur compounds, that's why it stinks. Sulfur compounds stink. But the sulfur compounds in garlic are capable of inhibiting various stages of the process of tumorigenesis. So good, rich, garlicky stuff, that's good for you. Fish, fat and protein. Roasted chicken, oh my gosh, crispy skin, lots of protein, that's good. And of course, my favorite, rare red meat. Now, people will tell you you can't eat red meat. They're lying to you. Red meat is darn good for you. There are a couple things you need to remember. Don't do processed red meat. A hot dog is not red meat. Okay? That's red meat. Also, you don't want to cook it much. If you cook it to the point that it turns really blackish, brownish, you do a chemical reaction on the skins of the protein on the surface. This actually generates carcinogenic compounds. So the blacker you make it on the outside, the worse it is. So you want to do moderation. Enough char so it tastes great, but nice and bright red in the middle. All right, quiz. Which of these is going to make you fat? Well, here we have Dunkin' Donuts. What is this? Fried dough and sugar. As soon as this stuff hits your stomach, it goes to glucose, your blood sugar goes to the roof, excess sugar is then converted to fat. Over here we have this bizarre hamburger with 4 patties, 8 pieces of cheese, tomatoes and onions. This actually isn't so bad. Now, the total number of calories in this thing might exceed your daily calorie requirement. You want to make sure it doesn't. But as long as it doesn't, the only thing that's bad here is the bun. All right, how about the drink that goes with all this? We have Coke, and we have 2 martinis. So the 2 martini after class drink. This is nothing but sugar water. Not only is it sugar water, but in the 70s when everybody started, the low-fat thing, the beverage industry realized that they could cut their cost by taking sugar out and putting in what was called high fructose corn syrup. Now, what is that? We start off with corn syrup. Corn syrup comes from real sugar. But you heat it and you process it, and as you do, you convert some of the glucose to fructose. Why is that important? Why is that important? Because fructose tastes maybe 10 times sweeter than glucose does. So you can put less in. You put less in for the same cost, and everybody's good. Only problem is that fructose does not set off the body that glucose does. So you eat this, ingest this fructose, and your body doesn't know that you have too much sugar. And so it immediately converts the fructose to acetyl CoA to fat. Immediately. Bad stuff, actually. With our 2 martinis, well, this is as many calories as sugars in alcohol. But remember, it is very, very inefficiently metabolized. Very inefficient. Now, your body metabolizes it quickly. Yes, it does, because it recognizes it as a toxin. So it metabolizes it quickly to get it out of your system. But it doesn't wind up as acetyl CoA, and so you don't get fat. Bottom line, the low-fat, high-carbohydrate diet that has been recommended worldwide for years is bad science. In fact, there was no science. They looked at these arteries and said, oh, there's fat in there. That's not science. A diet that's rich in protein with moderate fat, reduced consumption of grains and carbohydrates are probably best. Now, we looked at this meal. It's a gorgeous meal. I'll be honest, I love the martinis. I also like a little bread. But if you do the bread, you have to just think about it. This is sugar. Always think about bread as sugar. And if you eat enough bread, it's just like sitting down and eating a bowl full of honey. Not going to be good for you. Now, maybe 10 years ago, people kept telling the USDA that they were wrong. You know, come on, guys. Read the literature. This isn't the way it works. They were nonetheless still recommending low-fat, high-carbohydrate. The process of getting it recognized that high carbohydrate was bad, high protein is good, and even high fat is good, had huge, huge political barriers. Remember when we looked at the map, everybody in DC was skinny? Yeah, well, that was the former administration. They were all skinny. And there is nothing that you could say to these people to have them tell the world that no, you shouldn't eat fat. So they eventually came up with a new set of guidelines. USDA did. But the guidelines really don't do very much. We need another cycle. They do say limit sugar, but they still say saturated fat is bad for you. It's not. Saturated fat is darn good for you. It's a wonderful source of energy. Just do not exceed your basic metabolic requirements. That's all. It's wonderful. They also say you have to limit sodium. This is also wrong, apparently. And the latest research shows that sodium levels really have no effect. And so you can put salt on anything you want, and that's fine. High fat, high protein, low carbohydrate, but USDA isn't going to come around to that for a long time. Any question? All right, this was our last chapter. It was fun. One of my favorite chapters. When you think about nutrition, I guess the bottom line is everybody is unique. Everybody metabolizes things slightly differently. And so you need to find your own niche. But try to understand the basic science behind it. We have one more class on Wednesday, right?
Yes.
I will grade quiz 3. At the end of that, I will post the grades online, and I will tell you online if you need to take the final. How will you know? Because there'll be a column called grade. If you have an A in that column, you smile and you go home. If you don't, then we'll take the final. On Wednesday, we will do the sample final exam. It will be up online sometime. And we'll go over it. If you need to take it, we'll work that out next week. I believe it's officially scheduled for Friday of exam week. We'll probably do something slightly different.